What a coincidence that I met this person here. What a coincidence that I found my partner among 8 billion people. What a coincidence that we had the same idea at the same time. The question is, how much of that is real randomness? When a coincidence happens, the first question we usually ask is, how likely was this? But if you look at all the little events across days, years, and millions of people, it's completely normal that sometimes something happens that looks unbelievably unlikely or perfectly timed. That alone is enough to create coincidences. But we usually don't stop there. We start linking events. For this to happen now, that had to happen before, and before that something else, and so on. Pushed far enough, this becomes, out of all the ways things could have gone, why this exact path? It sounds deep, but it's actually the wrong question. Every fully detailed path is incredibly unlikely, but one path has to happen. So it's not surprising at all that your life story looks extremely specific and unlikely when you look back at it. That part is guaranteed. The more interesting question is, why do I single out this coincidence and give it such a special meaning? Some unlikely event was going to show up eventually. Our brain is what turns that bare fact into something special. Our brain is not a statistician, it's a pattern finder. It looks for connections, for meaning, for stories. That changes how coincidences feel. Imagine you think of a friend. Almost every time, nothing happens afterwards. You forget it. Once in a while, they text you right then. That moment sticks. It feels special. We remember the hits and ignore the misses. The same happens with noise. We see constellations in stars, faces in clouds, signals in random graphs, signs in coincidences. From one side, mathematically rare combinations are expected when you have many chances. From the other side, psychologically, we highlight those rare moments and wrap them in a story. So coincidences feel much more meaningful and mysterious than they really are. But what do the laws of physics say about randomness? In classical physics, the universe behaves, as far as we know, deterministically. Roughly speaking, an outcome feels random when we can't predict which result will happen, only the probabilities. Classically, that is usually because we lack information, not because nature itself is rolling dice. Take a coin toss. In principle, the result is fixed by the laws of motion. Initial position, velocity, spin, air, surface. With perfect information and enough computation, you could predict heads or tails. The same idea applies to a dice roll, and in a far more complicated way to the weather. In reality, we never know the initial state exactly, and tiny differences can lead to very different outcomes. That is chaos. Chaotic systems, like a double pendulum or the free body problem, react extremely sensitively to tiny changes at the start. To us, that looks random, but the equations behind it remain deterministic. In the classical world, random usually means the laws are deterministic, the system is very sensitive, and our knowledge is limited. Unpredictable for us does not mean nature itself is random. Or is it? On very small scales, quantum mechanics takes over. Before we measure a system, we describe it with a wave function. It gives probabilities for different outcomes, not defined values. When we measure, we get one specific result with a certain probability, not just a hidden value that was sitting there all along. Take a single radioactive atom. For many atoms together, we can say very precisely how long it takes until half of them have decayed. But for one atom, we cannot say when it will decay, only how likely a decay is per unit time. The exact decay moment seems fundamentally unpredictable. According to our best theories, this looks like real randomness, not just hidden details we haven't measured yet. How exactly to interpret that is still debated. But if we look for a place in physics where individual events might be truly random, quantum processes are our best candidate. Let's go back to our original question. How much of that is real randomness? We have seen three pictures. Coincidences that naturally arise from large numbers, a brain that searches for patterns, and a universe that is classically deterministic with quantum randomness possibly underneath. Our everyday world lives on large classical scales. There, deterministic laws describe things extremely well. Quantum fluctuations underneath mostly average out. For almost everything we experience, we can treat the world as effectively deterministic. So the coincidences in our life don't need fundamental randomness to exist. They arise from enormously many possible events, dynamics that are deterministic but chaotic, and a brain that turns outcomes into stories. From that point of view, coincidences in life are not truly random in a deep fundamental sense. They come from how a deterministic world behaves when it is large and complex, plus a mind that loves patterns. Although on the quantum level there may well be events that are genuinely random, how much that really matters for our choices and experiences is still unknown. For now, I would leave that question to you.